Okay. Today we are going to see the timing diagram of 8085 instruction execution. Right. Here we are having now that instruction execution. Here we are having that instruction execution is here we are having one operation is opcode fetch. Opcode fetch as here we are having now that right. So that we are having now that opcode fetch operation. So this opcode fetch operation, we are going to have that one. Right. Now the operation is opcode fetch. Opcode fetch operation. So that is we are having opcode fetch machine cycle. They may ask question about that machine cycle. Draw the machine cycle for opcode fetch. So that for fetching opcode, then what are the sequence of signal we are going to use for reading the opcode from the program memory, right? So here we are having the starting the program with that 8000 address. In that 8000 we are having now LXIH, that is 21. Then we are having now that in 8001 we are having now that 00, right? Then 8002 we are having now 90, right? So that is the instruction called LXIH with address 9000 hexadecimal. So that is we are having now that 3 line of code, right? So here this is the opcode. So the opcode is here we are having now that one as this is the opcode 21, right? Now the 21 is opcode. Now we want to read out from the memory to instruction register. So for that what signal we are going to have, right? So I told you that one clock pulse, right? So we are using the clock pulse for further processing, right? So now you see this one first clock pulse. So this is one clock, right? So from here to here we are having one clock, that is called 1t state. So in that one t state, what we are doing now, the 8000 is going to be placed. So higher order bit, so 80 is here, and here we are having now 80 is here. Then here we are having 80. Here we are having 00. So 8000 is going to be placed in address line, right? So A15 to A8 higher, and A0 to A7 is lower. So 8000 is going to be this, right? At the time we are having now the address latch enabled signal is on, right? So this signal is holding that address in the memory. Holding the address means enabling that address throughout until the another acknowledgement signal is going to be received. So that 8000 is retained in the memory enabled. Then in the next clock pulse we are going to use that 80 to 87 for reading data. So we are reading the data is we are reading the opcode. So that's in that address 8000 we are having that data. In that address 8000 we are having a data 21, right? So the 21 is going to be placed because the data address bus is having that the 8000 is enabled. In that 8000 we are having that value 21 is placed in the next clock pulse. So in that clock pulse, in that second t state, in that clock pulse we are having now this 21 in the data bus. Then here we are having now this data bus information is written until here, right? So that data is going to be placed in the instruction register. So at the time I told you that one, this is actually memory read operation. So memory read operation is here the memory is going to have the memory bar. So the memory bar is if you are having 0, then memory read operation. Here we are having opcode. For that opcode S1 and S0 and S1 is 1. So we are having fetching the opcode. So that is from program memory we are reading the data. So opcode fetching is going to move to instruction register. So in that instruction register we are having now the 21. Now the instruction decoder is going to decode and give the micro operation for loading this 9000 into address bus, right? 9000 in the address bus, and then from that 9000 we are getting the data to acknowledge this accumulator, right? So we are having LXIHs, we are having now LXIHs, we are having now HL pair register, right? So that is here in that this is 00 is going to have that L, and the 90 is going to have in H. So the HL pair is going to be loaded with the address, direct address, right? The HL pair is going to be loaded with direct address. Now this catchal pair is having as memory. Then from memory to from memory to acknowledgement we are having move memory to acknowledgement is next instruction, right? So that is LXH 9000, and then we are going to move a comma m. So that is from memory. That memory is the catchal pair address content to the, right. So in that 9000, what we are having now? Suppose we are having that value 30. The 30 is going to be placed on accumulator. That is another way, right? So the opcode fetching is going to have 3 t state and added with one more t state for idle. Actually that this state is idle, but we are using the up to 3 state for opcode. The totally we are having 4 t state is used for fetching that opcode, right? Then after that here this the data bus is not used, so the data bus address bus is going to be used until the reading the data. After that, then whatever it may be, you don't worry about that one. So the fourth t state is that here unconditional and don't care condition state. So that is we are having now for opcode page cycle, right? Like we are having now memory read from, right, memory read cycle. So this is for memory read. So what's the difference here, right? So memory read. So that one as here I told you that one 9000, right? So that address is 9000. So in that 9000 we are having the data. So that is memory read cycle, right? So in that memory read cycle we are placing that 9000 in the address bus, and we are doing that address latch enabled. Then this 9000 is enabled retain until the another ALE signal, right? So this is ALE is low, then it will be retained 9000 in the address bus. Then we are reading the data, so memory read. So that is this is 0, then this is 0, then we are having now 1, right? So this is not opcode, so we are reading the data. So we are reading the data, then we are having now that in that 9000 what's the current value, that value is going to be placed in data bus. Then the data is going to be used. Then in the next signal we are having move immediate a comma m. So we are having now this 30 is going to move to a, move to accumulator. So that is we are having in the next sequence of pulses. So that is we are having now memory read machine cycle. Memory read machine cycle is here move a, for a simple instruction is move a comma m. So reading the memory data, right? So how do you read a memory? So we are having that first you have to place address and we have to get a data in the data bus. Then thereafter then the data bus content is going to be moved to accumulator. So that is the next clock next instruction set. Okay, now memory write. So that memory write is here we are having now that memory write operation, right? So that memory write operations we are going to have now, right? So it's similar that the reading, now we are going to have write, right? So the signal changes here, right? So this is for writing. So that one is actually they are having now write operation, read operation, right? So that is here S1 is 0, S0 is 1, right? So here we are having that right. So that this is different, right? So this is we are having now 1, this one is 0. So that is we are having now that signal. We'll see that signal here as changing now, right? So that signal we are going to have now for write operation. So nothing other than change, right? So that is we are having now that this is the read operations. Then we are having now that this is memory write. So we are having now this is write operation. Instead of that read, then we have to give now write operation signal, right? So this is read operation signal. Right? So this is read, so memory read, then here we are going to write. So the write operation signal is going to give in the opposite directions. So here we are having now write operation, right? Then IO read. So IO read operations, right? So that is we are having now that instruction is called IN with port number, right? Port number. So this is IO address. IO addresses here we are having now the external IO device. Then the IO device we can connect with. Then each is having that unique number, right? So f of 0 to f of we can have now unique number. We can use now around 255 device we can communicate. Then we are having now we are having the instruction is IN80. So the port number 80. So that 80 is one device. That this is a unique device. So from that device we are having the transferring the data to your processor IN. We are receiving the data from the device 8 port number 80, right? So now how do you do that one, right? So we have to place the port address, right? So port address in the higher. So port address is here. Here we are having now the lower as well as higher, right? So this is we are having the 80. The same one we are having now here also 80, right? So this port address we are going to have now, right? So port address, actually the port address we are having now, we can extend that one, right? So that is here we are having now the 16 bit, then we can extend that one as, right? Otherwise then we can use that 8 bit. So that 80 is enough. Then this 80 is copied here also, then it will retain until the reading the data, right? So that 80 is going to have that one, right? So that 80 is a port address. This 80 is going to be copied in both places, right? So port address, 80 is retained until the reading the data, right? So now we are having now the reader data. So here we are having now IO read. So that is here we are having, this is one. The one is we are having IO operation, not memory operation. So we have to take the data from IO device. Then the port number is here. So this device is enabled. Because of the port number, this device is enabled. Then it can send the data to the accumulator. So send the data to the accumulator of processor, right? So here we are receiving the data. So that one is here 80. In that 80 we are having some data, right? So here 7F is one data. This 7Up is going to move in that bus, right, in the data bus to the acknowledgement. Data bus to acknowledgement, right? So the data is 7F. From which port? 80 port. Port number 80, we are receiving the data. The 7Up, the processor, the device is giving the data as data, right? The data is going to be used. So here we are having now IO read operation. So this is 1, this is 0, read operation. Similarly IO write operation. So that is we are having now the S1 is 0, S0 is 1. Then there is no change, right? So write cycle. So instead of read cycle we are having now write cycle. Read cycle number. It's not right. So this is the write cycle. We are having a write operation. Read operation and write operation is separate, right? So the write operation is going to have now that low, then we are having now the corresponding write operation, right? Next one is we are having now that move immediate A45. So that one is here we are having now, this is all cases are we are having now that T3 state, right? 3 state, then opcode which is 4 state, right? Then here we are having now this move immediate A45 is actually 2 byte instruction. Move immediate A45, move MBI A45, right? So that is we are having MBA move immediate A is one opcode value, then followed by we are having now that 45 case. So we are having that in memory we have to read the two data, right? One is opcode page, another one memory read, right? Opcode page and memory read combined together, right? So this is until that one, this is opcode page, and then we are having the 3 status for memory read. So we are having now that opcode page is one part, then we are attaching that memory read. So the totally we are having 4 plus 3 7 T state is required for the move immediate A comma 45. Move immediate A comma 45 is required 7 T state. Now stored accumulator in the address 8000, right? So here we are going storing that accumulator content into address 8000, right? So here we are going store accumulator 8000, so you consider as 9000, right? So that is we are having storing the address in 9000, or if you are having that data, right? So 8000 is we are using now that for program memory 8000, so you use that as 9000, right? So stored accumulator with 9000, right? Then we are having the opcode is 32, then followed by the lower byte, and then we are having higher byte. So this is 3 byte instruction. 3 byte instruction. So stored accumulator is 3 byte instruction. So one opcode to the address, right? Lower byte and higher byte. So we are having 3, right? So then we need, this is 7, this is 3, this is 3. So totally 10 D state is required for the stored accumulator. Store accumulator STA. Here you see this one. We are having now that 4 D state is used for. So this is we are having now this for STA, right? So that is we are having now first one is read opcode page. So 32 is going to have now opcode page instruction. So that one is we are going to do that one, right? Then we are having now the this here we are having now the next. So that one is here 1001. So the next address we are having now, right? So this is actually we put as a starting address is 8000, right? So this is we are having now that 8000 is starting address. then next is 8001. So now we are reading the lower byte, so lower byte is 00, right? Then we are going to read that higher byte is 90, right? The data higher byte is 90. Then here we are having now t1 t2, so that is up to that one, right? So that is we are having now, this is 2 to 3 plus 3 is 6, and then we are having now 4, right? So this is for upcode page, the 32. Then we are having that this is for lower byte 00, this is for higher byte, right? Then we are going to have now some other next data we are going to have that one, right? So that is we are having now the 10 d state for the stored accumulator. Next one is INRM, right? So we are having now increment the memory location content. INRM is INRM, increment the memory location conditions, right? So that is in the KHL pair we are having an address. Suppose we are having that 9005. In that 9005 we are having some value, right? Then that value is going to be incremented, right? So if you are having 45, then this is going to have that increment by 46. So that is the operation, right? So what actually we have to do, then we are having that opcode for this particular INRM, right? One value will be there, then first it will fetch the opcode, then we are having now reading the data 45, and then we are incrementing the data as 46, and once again then we have to writing the data, read and write operation is required, right? So that is the opcode fetch cycle. Then we are reading the data, right, on the corresponding location, then increment, and then we are placing the data into the same location, right? So that is we are having now that INRM. INRM is the HL pair address content is going to be increment. So that is the instruction. So that instruction here now you see this one up to that T1 to T4 is we are having opcode page cycle, right? So the same one is repeated now opcode page cycle, right? So that is we are having now the corresponding address, then we are having now the corresponding value, then we are having this is the lower byte, we are now that one as here we are having now this value is reading that data in the particular address, and then we are having the writing the data that here we are giving that E1, right? So here if you are having 45, so that is 45, then increment by 146 here. So we are place writing the data, right? So the read and writing data. So that one is here read, here we are writing. We are reading the data, then writing the data. So reading the data is 45 is reading on the location 9005, then increment and writing the data is 46 here, right? So that is we are going to have now that opcode page. The opcode is here we are having now that for example we are having 34 or something. So opcode fetching is going to happen now, reading, then we are having now then we are reading the data, and once again we are writing the data. So that read and write operation. So read operation is using the signal, write operation is using the signal. Then here we are selecting the IO or memory. So this is IO operation only. So we are having now that for all cases we are going to use that IO operation, right? So this is IO or MS 0, then IO or MS 0, then here also IO or MS 0. So that is the instruction cycle for INR M, right? So they will ask the corresponding instruction, then you have to draw the timing diagram, right? So these are all the possible. So if using that this set of timing diagram, then we can write for any instruction. So you go through that instruction and then we can draw the corresponding diagram, how many number of t state, then how do we communicate. So this is actually timing diagram for many instruction. In the same way then we can draw the machine cycle or timing diagram for all other instructions. So you have to be thorough with this set of diagram, then you are able to solve for all other instruction, and you can draw the timing diagram for whatever the instruction it may be. So almost in that question any one of that particular instruction only they will give, so you can draw that diagram. So you have to be thorough with this set of diagram. Okay, we can stop here, then we will continue by next class.